Okay, the next question is question number 12 from the Unit 2 practice test. So question number 12, it is assume that the heights of men are normally distributed. So the keyword normally distributed, make sure that you draw your bell curve. It will already be on the test for you, provided to you at no additional cost. Then we have a mean of 69 inches. So the mean is the highest point. So you write in there 69 inches. And it's good to write it on the sign with the proper notation of the population mean. That is 69 inches. And a standard deviation of 2.8 inches. 2.8 inches. Then it says, if 64 men are randomly selected. So the fact that is giving us the sample size tells you that we are in section 5.4 and that the formula to use to standardize the X score is going to be the X bar, the sampling mean, minus the mean for the population, divided by the standard deviation over the square root of the sample size. So the question here is, find the probability that they have a mean height between, keyword between, 68 and 70 inches. 68 inches and 78 inches. So if you go back to the drawing here, 68 is before 69. So you place that number before 69. 70 is after 69. So that will be to the right of 69. And between means is that we're going to shade those two values. So these are the X values that we need to standardize into the Z scores so that we can find the probabilities. So in terms of the probability notation, this is going to be the probability of the X scores be between 68 and 70. And then we convert those to Z scores using the formula for the sampling distribution. So this is going to be 68 minus 69 divided by the standard deviation of 2.8 over the square root of 64. The next one will be 70 minus 69 divided by the standard deviation over the square root of the sample size. So you will enter that in the calculator, and remember that make sure that you use the proper parentheses in your calculator. So I have here in display the Dora de calculadora. I'm going to clear the screen and move this to the side so that we can see the calculator and see what we're going to enter. So I like to enter the numerator in parentheses, 68 minus 69, close the parentheses, divided by, open parentheses, 2.8, divided by second, the square root of 64. And this calculator, I don't need to add parentheses, but make sure that you check that with your own graphing calculator. Each one of them is a little bit different. And then you press enter. So your Z-score is always 2 decimal places. We don't have to tell you to round it to 2 decimal places. It is understood that you will use 2 decimal places. So negative 2.857 will be rounded to negative 2.86. So that will be the Z-score for the X value, that is 68. So negative 2.86. Now we're going to enter the second X value to standardize that X value. So open parentheses, 70 minus 69 divided by, open parentheses, 2.8 divided by second square root of 64, and close the parentheses, enter. So now this Z-score is 2.857, so it's 2.86, positive 2.86. So the z-score for 70 is positive 2.86. The z-score for 68 is negative 2.86. I will show you how to get this answer with a calculator. So notice that the z-scores, they're the same. One is positive, one is negative. So I'm going to clear the screen. We're going to go to second vars, option 2. And the lower is going to be the negative 2.86. And the upper is going to be the 2.86. Everything else remains the same. Just keep entering or moving the arrows and press enter. And the calculator will take care of the area between those two z-scores. And the probabilities will be 4 decimal places. So this one will be 0.9958. That will be your final answer. Again, you can use the z-score tables or you can use Dora de Calculadora. She has everything inside of her. Thank you.